Difference between discriminative and generative models in detail. Discriminative and generative models are two broad categories of machine learning models used for different purposes. Understanding their differences is essential for selecting the right approach in various machine learning tasks, including classification, speech recognition, and image generation. Definition: discriminative models learn decision boundaries to separate classes. Generative models model the full data distribution, allowing data generation. Goal: discriminative models find relationships between input features, X, and labels, Y. Generative models learn P, X, Y to understand and generate data. Output: discriminative models predict class labels directly. Generative models generate new data similar to the training set. Examples: discriminative models, logistic regression, SVM, random forest neural networks. Generative models, naive Bayes, GANs, VAEs, HMMs. Use cases: discriminative models, classification, spam detection, fraud prevention. Generative models, image/text generation, speech synthesis. Performance: discriminative models, more accurate in classification. Generative models, better for unsupervised learning and creativity. Computational complexity: discriminative models, more efficient. Generative models, computationally expensive due to full data modeling. 2. Discriminative models, learning decision boundaries. What are discriminative models? Discriminative models focus on distinguishing between different classes by learning the boundary that separates them. Instead of modeling how data is generated, they learn the direct relationship between input features, X, and labels, Y. Mathematical formulation: discriminative models estimate the conditional probability P, Y divides X, P, Y, X, P, Y divides X, where XXX represents the input features. A YYY represents the class labels. These models do not try to model the distribution of XXX. They only focus on predicting YYY given XXX. Examples of discriminative models: 1. Logistic regression, a simple linear classifier that models the probability of a class label given an input. 2. Support vector machines, SVMs, finds the optimal boundary, hyperplane, to separate classes. 3. Decision trees and random forests, partition data based on feature values. 4. Neural networks, deep learning, learn complex decision boundaries through layers of neurons. Advantages of discriminative models: higher accuracy in classification tasks when enough labeled data is available. A less computationally expensive, no need to model full data distribution. More straightforward implementation for supervised learning tasks. Disadvantages: cannot generate new samples similar to the training data. Requires labeled data, making it harder to use in unsupervised settings. 3. Generative models, learning the data distribution. What are generative models? Generative models aim to learn the underlying probability distribution of the dataset. Instead of just drawing a decision boundary, they understand how the data is structured and can generate new synthetic samples. Mathematical formulation: generative models estimate the joint probability distribution Px, Y, Px, Y, Px, Y. From this, they can derive P, Y divides X, tongue sticking out X, Y, P, X, P, Y, X equals \frac P, X, Y, Px, P, Y divides X, tongue sticking out X, P, X, Y. This means generative models first model how data is generated and then use Bayes' theorem to classify new data points. Examples of generative models: 1. Naive Bayes assumes independence between features to compute probabilities efficiently. 2. Hidden Markov models, HMMs, used in sequence modeling, such as speech recognition. 3. Gaussian mixture models, GMMs, used for clustering and density estimation. 4. Generative adversarial networks, GANs, generates realistic images by training two neural networks, a generator and a discriminator. 5. Variational autoencoders, VEs, learns compressed latent representations of data and generates new samples. Advantages of generative models. A can generate new samples similar to training data, e.g., realistic images, synthetic text. A can handle missing data better than discriminative models. Useful in unsupervised and semi-supervised learning. Disadvantages. More computationally expensive since they model full data distribution. May require more data to accurately learn complex distributions. Can be harder to train, especially GANs, which require balancing two neural networks. For real-world example, email spam classification. Discriminative approach. A discriminative model, e.g., logistic regression, directly learns the decision boundary. If words like free, money, offer appear frequently, classify as spam. If the email is from a known contact, classify as not spam. Here, the model focuses only on differentiating spam versus non-spam without modeling how emails are structured. Generative approach. A generative model, e.g., naive Bayes would 1. Learn how spam emails are typically written, e.g., high frequency of promotional words. 2. Learn how non-spam emails are structured. 3. Compute P, spam email content, using Bayes' theorem. The generative model first models how both spam and non-spam emails are structured before making a decision. 5. When to use discriminative versus generative models. Scenario best choice. Classification, spam detection, fraud detection, sentiment analysis, discriminative models. Generating new data, images, text, speech synthesis, drug discovery, generative models. Unsupervised learning, clustering, anomaly detection, generative models. Handling missing or limited labeled data, generative models. When computational efficiency is required, discriminative models. Rule of thumb. If your goal is prediction/classification, go for discriminative models. If your goal is understanding the data structure or generating new samples, use generative models. 6. Hybrid approaches. In some cases, combining both types of models can be useful. Semi-supervised learning. A generative model can learn from unlabeled data, while a discriminative model is fine-tuned on labeled examples. A GNs with classifiers. GNs, a generative model, can generate high-quality images, which are then classified using discriminative models. For example, GPT, Generative Pre-trained Transformer, is a generative model trained on large text corpora, but it can be fine-tuned for discriminative tasks like sentiment analysis. Conclusion. Both discriminative and generative models serve unique purposes. Discriminative models are great for classification and decision-making tasks. Generative models are powerful for unsupervised learning, data generation, and handling missing data. Understanding the strengths and weaknesses of each helps in choosing the right approach for your machine learning problem.